Hello. Hi everyone. Thank you for coming to listen. A quick intro. I'm Paul Clarkin. I am Head of Engineering at thinkmoney. And I'm going to talk to you about how we rebuilt our banking platform, moving to a serverless architecture in around 9 months. A little bit about thinkmoney. So thinkmoney is an electronic money institution. We're based not far from here. We're just over the water in Trafford Park, just over that way somewhere, just near Man United's ground. We've been offering various financial products to customers for over 20 years. But these days we're primarily focusing on our current account. And that's the part of the business that I work in and that this talk focuses on. This presentation is not intended to be a how-to guide or a warts and all kind of review. It's just a bit of a view and a story about what we did and how we did it. I'm sure there'll be things that I will miss out and there'll be some details that you might be interested in. So if so, feel free to grab me later on and we can have a chat. Most importantly though, while I'm up here talking about it, I'm not going to take any credit for any of the work. Our fabulous team of hardworking thinkers, some of which are actually on that screen, across the entire business did all the hard work really. So I'm just going to stand here and talk about it. So a little bit about where we were. So we've been in business for over 20 years. So as you can imagine, we've had a few technology platforms in that time. And technology generally has changed in the industry through all that time as well. So when we set off on this sort of journey, we were running on our sort of second major iteration of platform as a bank, and we were primarily running .NET. At the time, we were running version 4, we were running C# APIs, and we were all running on Windows servers, and they were sort of hosted on-prem in kind of physical data centers. All this supported Android and iOS mobile apps, and we were using a low-code platform. We were using OutSystems, and this all sat on top of a Microsoft SQL Server. That SQL Server was full of business logic, which was all buried in untested stored procedures. In fact, there was very little automated testing throughout the entire stack, meaning large reliance on manual, functional, and regression testing, which of course means lots of things get missed, and there were lots of issues which came up, causing customer impact and internal impact, lots of bugs and outages. Additionally, we were missing what we've heard today are really fundamental features: limited failure handling. So our customers would frequently suffer outages. There was limited observability, meaning our teams didn't know there was an issue until we were getting calls from our call center telling us that there was a problem. There was limited disaster recovery, meaning it took us a long time to recover and get things working again when things did go wrong. Generally, we were just struggling to then grow as a business. Technology was one of our largest constraints. Our systems were starting to creak as more customers joined us. Overnight batch process was starting to take longer to run than there are hours in the night. Our physical servers were regularly suffering hardware failures. Frequent connectivity issues with third parties causing outages on our systems, and the inability to offer customers standard features such as Apple Pay or Google Pay. So we've been trying to improve that system for a long time, but it was starting to get too complex and really intertwined. So as an example, back in 2021, we wanted to update the version of .NET. As I mentioned, we were on .NET 4. So we started looking at how we could update that, but actually we were also running on an old version of Windows Server. That would need to be updated because that didn't support newer versions of .NET. But actually when we went to do that, the data center provider said, well, actually, your underlying hardware is now out of date, out of warranty. We need to change the physical server. Oh, but also VMware's now needs update. So the whole stack needed to be replaced in one way and another one. And that kind of comes to a point from earlier on, actually. We left it very, very late. We should have been doing that a lot more incrementally, but we'd got to that point. The developer experience on the stack was really poor. Our OutSystems low-code platform was just not inspiring for our team. and didn't encourage modern best practices of code management and testing. We struggled to recruit and retain developers. Something needed to change. So we started doing a bit of planning. So we started planning in 2022. So this is where the title, this is a little bit misleading. We didn't do it in 9 months. There was a lot more to it. But before we started building, we spent a lot of time designing our architecture and also looking at the technologies that we want to support it. We did have a bit of a luxury that the business was starting to really understand that pouring good money after bad is not going to work anymore. So we slowed down the BAU on our current platform, which then gave space for the senior team to then start working with chief architect and the rest of the wider team to really understand potential solutions. Quite quickly, it was obvious that most parts of the system needed to be changed. But we're really interested by the relatively new concept of serverless computing. We've been using AWS for a while, and we've been using it on some smaller areas, and actually experimented with a little bit of Lambda. And we were really keen on the efficiencies that it offers. Most of our processes don't run 24/7. So in banking, for example, you've got direct debits that get paid. They actually get paid in one big batch, and ours get paid first thing in the morning, and then we don't touch direct debits for the rest of the day. So direct debit processing, natural fit for something like that, where the on-demand model is a little bit more of a good fit. One sort of key decision we made is to lock in very early on, is to lock in with AWS. We decided that AWS was going to be our vendor of choice, and therefore we avoided any concerns and complexities of trying to support multiple vendors. We didn't look at any of the frameworks like Kubernetes or anything like that. We've kind of gone a little bit more direct with it. We've taken that as a risk, and we understand that if we need to change, there'll be a cost, but we don't see that be something we need to do in the near future. And obviously, while we were working from fresh, we just ensured that we had all the best practices in place. So things like appropriate roles being set up in Amazon, setting up the permissions correctly, following principle of least privilege. Don't let any of the developers have console access, and make sure everything is then automated as infrastructure as code. So we started looking at serverless in a bit more depth. So serverless generally was new to the engineering team. So we started doing some learning, started doing some proof of concepts. So out of the box, if you're familiar with Lambda, you'll probably know a little bit about this, but out of the box, Lambda natively supports 7 languages. But it's got an API that actually allows you to plug in some additional ones should you wish. So we started looking at those languages and started to understand their strengths and weaknesses. And our initial online reading and research told us what the rest of the world was using, but what was best for us. So we were already using C#, we had .NET experience, so we started off there looking at C# on Lambda, but also things like Node.js and Python were very popular in the industry. But Go was a language that the developers were really starting to talk about, to read about, to learn about, and we're very interested in trying. And when we learned that was kind of natively supported, we added that to our shortlist for deeper analysis. So obviously we've done a lot of reading online, and we were impressed with what we were seeing, serverless pattern growing in adoption, and the development team had started playing around with Go, actually writing some code, writing some hello world and then some. And we're really starting to enjoy its ecosystem and implementation. But the research only took us so far, so we started to actually test out the data for ourselves. We started out with a sample REST API, and we built it in Node.js and connected to a Dynamo table. So a lot of the basic things that we would want to do day in, day out. And we were quite happy with the Node.js results. We saw some really good speeds, which were actually loads faster than what we were used to in our .NET world. So it was very, very impressive. And then we tried some Go. Go is much faster. It's got a smaller memory footprint. And when we actually did the test, those numbers on there we had to triple check because we actually thought we'd got a unit wrong. when it said 5 milliseconds, we thought it must have meant 50, but we triple checked it and it actually was 5 milliseconds. Now, it was a simple proof of concept. There was probably a lot of optimization that we could do, but it was enough there for us to go that we're going to make a decision and start moving forward. So we decided that we will build APIs and services in Go, and we'll use Lambda until there's a case that doesn't fit that model. So talking about cases that don't quite fit that model, one example of a case is where we've decided to use Docker containers, and we're running in ECS. So one challenge we were finding with serverless functions is that it can suffer from cold start delays. Now, this is supposed to be in the minority of cases. Amazon say it's about 1% of the invocations, and there are lots of options to provision and keep functions warm. But for the majority of our services, we've decided that cold starts are acceptable, and especially at the amount of cold start, the time taken for those cold starts. As an example, when customers make payments with their card in a shop or online, that transaction is sent to our system for us to approve, and that approval has to be returned back through the wider banking network all the way to the merchant terminal within 500 milliseconds. Otherwise, that payment gets declined. So we've decided that we'll have warm ECS containers, and we'll take that precautionary step. However, in hindsight, we actually think that it's probably something we didn't need to do. We get enough traffic to that payment service that it probably wouldn't have gone cold. But it's something we've got on our backlog to look at in the future. We initially also oversized it. We had about 6 tasks running, but after a few months we could see that we were massively over-provisioned, and to the earlier point of cost savings, we brought that down to 3. So everyone loves some diagrams, architectural diagrams in these kind of talks. You don't have to look at all the detail, but just this really is to highlight the complexity of our system. At a really high level, thinkmoney just simply orchestrates messages from a customer to a wider banking network and other third-party systems. We rely on a sponsor bank and a third-party core banking platform to provide that interface to the wider banking network, which does reduce complexity somewhat. However, there is still a lot that we have to integrate with. But our main architecture pattern involves handling requests from our public APIs via an API gateway, and then we hand off to an appropriate Lambda function. So there's a massively simplified picture of our overall architecture there. We use SQS throughout for message queuing, just to provide an additional layer of resilience, and that allows messages to be saved should a service fail to process it. We've got the option to retry later, and for some of those messages we can, for some of those messages we shouldn't. But that gives us, the confidence to have a 24/7 service. If we roll the clock back a few years, thinkmoney was in a mentality that it was acceptable to have planned outages, planned downtime, and you might still see it with your banks today, that they will have planned outages at 2 a.m. on a Sunday. We have decided that our customers want a 24/7 service, and I think you probably would agree. You might want to be paying for an Uber at 3 a.m. on a Sunday. A planned outage isn't going to help you there. So we really want to make sure that we've got 24/7 service at all times. The estate's made up of over 30 services. They're deployed and managed in a microservice style, and this has allowed independence between the components, and that's allowed for really rapid changes and releases. As with any microservice architecture, it brings big challenges and complexity, such as dependency management and design consistency. This is a problem the team has worked closely on through collaboration, and we're automating our standards as much as possible. So we're using things like code linters in the build pipeline, and we'll be looking at some of those things that came up earlier as well. That's interesting. This all supports our new React Native app as well. So we built a new app at the same time. started to get a little bit madness with the amount of things we had to rebuild, but the old system was so tightly coupled, and we had some very tight timescales that we were trying to achieve, that we really needed to do everything in one go. But by following a clean RESTful architecture and ensuring that all business logic stays in the API levels and not the app, it's made the app a lot quicker to change and easier to maintain. And we've had a huge reduction in the amount of defects in the app being raised by our internal teams and also our customers. So as I just mentioned, we had a really tight timeline on this, and obviously in the title we talked about 9 months. We had some third-party constraints placed on us very early on, meaning that we had to lock down to a migration date. This was set as the 16th of November 2023, which is now ingrained in all of our minds. We're mainly constrained by the fact that the banking network as a whole can't cope with us having 2 banking systems running at a time. When you make a payment or you move money around, you'll be all familiar with your account number and your sort code. That sort code is basically a routing for the network. So that sort code was able to be pointed at a platform, and we were able to then migrate it to our new platform. But we could only do that once. The rollback on that was to wait a week for the following change. So NatWest would make that change, and as I just said, it's a 1-week release window. So we then were constrained by that, and we titled it our single migration event. You might know it as a big bang. We try to avoid that term because it's a little bit ugly, but it's the same thing. That meant we had a lot that we needed to make sure we were in a good place. We also had to inform the Financial Conduct Authority, the FCA, who regulate financial institutions. We had to inform them of the change and ensure that we had consistent paper trail throughout the programme. But that doesn't mean we were drowning under piles of paperwork and red tape. We just used tools like Confluence and Jira to document our designs and decisions, and that's more than enough to satisfy all the auditing side that we required. We needed relevant levels of detail in our tickets, so tickets that just had a headline weren't quite enough for us, but it didn't stop us following an agile development approach. I mean, in fact, the agile approach with small sprints of work, with frequent demos and show and tells to the programme board, ensured that the programme stayed on track and all the stakeholders stayed engaged and happy that we were progressing on track. So even if you are constrained with a single migration event or a big bang, you can still carry on those agile practices throughout the programme. We're a small business. We don't have many layers in place. Internal decisioning is very streamlined. And we had 100% focus from all areas of the business. This was the business's #1 priority. Major decisions were often made within 24 to 48 hours. We would make a decision and we'd move forward. If that decision was wrong, we would change it, but we didn't want to be drowning under analysis paralysis, for example. We had multiple independent delivery streams. Each had their own work stack, which had minimal overlap. So this enabled lots of autonomy, and each team could solve issues, but they would work closely with a senior team of developers, architecture, business analysts, and product owners to make sure everyone was aligned. Followed a shift-left approach, so therefore, which means all of the responsibility for an ownership of quality is early in the process. So developers are responsible for writing and running automated tests, ensuring they run in the pipeline along with open source scanning tools to check for vulnerabilities and any coding issues. And we scripted the whole stack using infrastructure as code. We use SST, and that meant we were then confident that our development and test environments were live-like, and we were able to rebuild it at any point. So the largest challenge we sort of faced of this full rewrite is understanding what the system currently does. And we were really fortunate that there was a lot of domain knowledge in the business, but that didn't cover everything. We had a fantastic team of BAs that worked closely with subject matter experts, but really what we tried to do is avoid looking at what the current system did and instead considered what we would build if we were starting afresh. As sort of mentioned earlier, we made a decision to use new technology. So there's a risk there, but we were careful to not be bleeding edge. But we definitely were leading edge in some of those areas. But there was a learning curve with that. And that was one of our challenges. We had to take a bit of time, and the team had to take time to learn. But we had a bit of an opportunity before the main build started for the team to get into learning some of those techs and playing with them. One little challenge we faced was quite late on in the project. We realised we hadn't actually focused on the migration parts of the programme. So the actual scripts to extract the data from the old system and transform that to the new scheme and upload it. We did do that, but it was a little bit stressful at the 11th hour. We really needed to grow the team, though, to achieve what we wanted in the timescales. And we needed a much bigger team. Call out to a couple of agencies we worked with, as And Digital, Hyperact, and Dozer Consulting. They really helped us. We tripled the size at one point. And yeah, I'd recommend any of them if you need some help. Scaling a team quickly is hard work, though, and obviously it takes time to get the right people in, and obviously make sure that they've got the right skills, and also make sure that they get the domain knowledge as quickly as possible. There's obviously a lot of domain knowledge that we had as a business, and people who were coming into us, particularly as consultants or contractors, were very unfamiliar with banking as a whole. So we would need to do a lot of knowledge transfer with them. And the final challenge which we really faced was the legal side of things. There was lots of contracts that needed to be signed, but we made a decision to proceed at risk with some of these. One contract wasn't actually signed until the week of go live, which would have been fun if it hadn't been signed. But spoiler, we did it. It was in the title, so you might have guessed. But it wasn't easy, and rebuilding any platform in 9 months is not easy. Building a whole fintech platform with hundreds of thousands of active customers was definitely hard work. Only suffering minor issues on the morning of switchover was something we were very happy about. And one thing we were quite happy with is things around the costings, as we've now reviewed. Open source and free software has been used where possible to keep costs down. And our Amazon bill is in a good place. We obviously have a lot more in Amazon than just our Lambdas, but we're only paying about $100 a month for our Lambdas. In comparison, we spend about $800 a month on ECS. So it's definitely one we're going to be reconsidering. We are about to scale up, so those numbers are going to get bigger as more customers come on. But we're very pleased about the cost on the Lambdas. We actually thought it was going to be a lot more, but it's turned out to be lower than we expected. I mean, one of the big changes has been how much easier the platform is to change and maintain, monitor and release. For example, we rewrote the application onboarding process a couple of weeks after the initial go live, and it took us 8 weeks. When we did that program a few years earlier, it took about 5 months, and it was a lot harder because we were constrained by so many of the technologies that we had in place. And we choose to release our app changes once a week, but we release our API changes throughout the week. We've embedded open API specs into each API, and we generate those during the build process as well. Monitoring is much easier than where we were. We've got CloudWatch and the alarms, as kind of mentioned in previous talks. The alarms are kept in the code, so we maintain our infrastructure as code policy. Overall, the platform is performing really well and helping thinkmoney grow. And I got a couple of quotes from actual developers. Tom said it's miles better, and that's all he said. Terry now remembers what sleep is. Terry was getting called out a lot, but now he sleeps most of the night. Ian then gave us a sensible one of a much more coherent design. Nice, coherent answer from Ian. But the developers are much happier. They're in a much better place, and overall it means the team is in a happy place overall. So thank you very much for listening. As I say, it was just a bit of a story about what we've done. you guys might be doing something similar or wanting to do something similar in the future, and it'd be interesting to hear from you in the future. If you've got any questions, come grab me afterwards.